Welcome to Module 204B on relays and contactors. Now there's a lot of different jobs that are accomplished with the help of a relay or contactor, such as safety devices, multiple circuit control, or circuit isolation. What we're going to look at in this module is the design, the operation, the function, the theory, and the terminology of our electromagnetic switches. This module is split into 7 different objectives, and we will have one video for each objective as you go through. Let's start with objective 1 and look at the different types of relays and contactors that you might see in the field. If wall switches are mechanical switches, then relays and contactors are electromagnetic switches. And this means that the switching action is done because of an electromagnetic field. And there's a number of different reasons that we do use relays. We can use it for safety, whereas we can separate the controller from any dangerous voltages that our equipment might require. And we can also prevent a system from re-energizing after power failure. We can use relays for automation by using sensors to activate the relays, which in turn activates different electrical systems. And we can control multiple circuits at the same time with the same control device, which gives us a lot of adaptability as well. There are a number of different types of relays that are found inside our market, and we're going to discuss some of the more common types that we can see in the field. Firstly, we're going to talk about our plug-in relays. The plug-in relays have pins on the bottom that are inserted into a terminal base. The advantage we have with these is that they are very easy to replace if we need to change a function or if we just need to change the actual relay itself for maintenance. They're considered general purpose relays and they are available in different arrangements, but they usually have a maximum of a 15 amp rating, so we can't use these for higher loads. For heavier duty applications, we would use an industrial control relay, and these are commonly used for switching circuits with lighting and motor controls. An advantage that we have with the industrial control relays is that we can put additional contacts on by putting on what are called add-in decks. Power relays are typically used for loads up to about 30 amps, and they're used for small motor and heating loads. But these are not used for high cycle rates, so we don't want these switching on and off rapidly or frequently. All the contacts are exposed, so when using these, we must make sure that the parts are protected from any unauthorized access. For certain lighting applications, we can use low voltage lighting relays in order to use a low voltage control to control a high voltage lamp. A unique part about the low voltage lighting relay is these are called latching relays, which means that they actually have 2 coils on the inside, and as I energize either coil, it's going to move the armature to one side or the other, and that armature will latch into place until we apply voltage to the other side. Typically, these controls are under 30 volts, and we have to make sure that whatever relays that we're using are going to match the same manufacturer for our switches. Most of the electronics that we have in our house and in our businesses use solid state relays. These electronic devices don't have any moving parts, and you'll look at these more in 4th year. For higher power loads that would require more frequent operations, we can use a contactor. They operate like a relay, but they can operate higher current loads. We typically use these for motor starters and lighting circuits, and there's 2 different types of contactors that we can use. One is called the NEMA, which you see on the bottom of your screen, and the other type is called IEC, which is on the top of your screen. And we'll discuss more about the differences between NEMA and IEC as we go through the course. A special type of contactor that we have is called the reversing contactor. And these are actually 2 individual contactors that are joined together, and between the 2 we have a mechanical interlock. We don't want both of these to be energized at the exact same time, so the mechanical interlock actually blocks the armature from moving. So if I have one contactor energized, the second contactor cannot be engaged. A very unique type of contactor that we have is called the mechanically held contactor, and we use these in order to reduce any noise or power consumption by the coils. These contactors have 2 coils similar to the low voltage lighting relay, and the position of the contacts will change as I change which coil is being energized. However, the coils are only momentarily energized. These are also known as latched-in contactors. The last contactor that we're going to talk about is the definite purpose contactors, and these are typically found in air conditioners and rooftop units. These are built for the air conditioning compressor load, and they have a higher power application. You've reached the end of 204B Part 1. Make sure you're going through all these different types of relays and contactors inside your module until you understand the purpose of each one. Each has a definite application that we can use it in, and it's your job to understand which application would require which relay or contactor. Once you're comfortable with that information, return to Blackboard and you can continue on to 204B Part 2.